Swayam Prabha. Digital India. Educated India.
Hello friend, welcome to the course Foundations of R Software, and you can recall that in the last lecture we had talked about the matrix operations. Actually we had learned that how we can define the matrix in the R software, and we had learned that there were three main ingredients like a number of rows, number of columns and data which are needed to define the matrix in the R software. And after that we also had learned about the by row operation, that if you want to assign the values column wise or row wise. So now we continue on the same lines, and in this lecture we are going to take up some more operations which are related to the matrix theory, and essentially these are very simple operations and which are related to rows, columns and some more operation like transpose, etc. So we begin our lecture and we try to understand these concepts, that how you can implement them in the R software. So consider here a matrix in this particular format, that there are 4 rows and 3 columns, and data I am giving here say from 1 to 12. So this is another way of giving the data like as 1, 2, 3, 4 up to here 12. And you can see here there are 4 rows and 3 columns. So we need here 4 3s are 12 number of values which are given here from 1 to 12. So now this gives us this following matrix. So you can see here, this is my first row, this is second row, this is third row, and this is here fourth row. And similarly here, this here is first column, this is here is second column, and this is here third column. You just try to follow my pen, right, where I am writing. So now you can see here that this rows and column, they have got some name. For example, in case if you try to look at this row number 1, so it is indicated by square brackets like this one, then 1 and comma. And similarly, in case if you try to see here this row number 2, this is indicated by square brackets 2 comma, and similarly this third and fourth row are also indicated by square brackets 3 comma and 4 comma. And similarly, if you try to look into the columns also have been given a name which is a square bracket, then comma and then 1. This is column number 1. Similarly, column number 2 here is a square bracket, then comma and then 2, and third column is like here square brackets, comma and here 3. So these are the names which are automatically given by the R software to these rows and these columns. And suppose we want to rename these rows and columns, that we want to give them another name of our choice. So in order to do this, we have a command here, row names, ROWNAMES, and inside the parenthesis you write X and then COLNAMES, that is call names. This will rename the names of the columns. So if you try to look here in these 2 operations, suppose I want to change the names of the rows, and suppose I want to give them a name like say R1, R2, R3, R4 like this. So for that I write here row names all in lower caps, and inside the parenthesis the name of the matrix, and then I use the C command to create a data vector, and then I try to give these names within these double quotes. You can see here. So these are the characters. So this will work like that. I want to change the names of the rows in the matrix X with these names, and if you try to operate it, it will change it. For example, now if you try to see at this outcome, you can see here this is now changed. Okay. And now similarly, if you want to change the names of the columns here, which are here given here like this, so I use here the command COLNAMES, call names, and inside the parenthesis I write the name of the matrix X, and then I try to give the names which we want to replace. So suppose I decide that the names of the columns are going to be C1, C2, C3, so I So, I try to give them in the format of data vector using the command C within the parenthesis and all the names inside the double quotes, so that they are the characters. And if you try to execute it, then this function call names will change the names of the columns of this matrix X, and you get here C1, C2, C3. So, this is how you can rename the names of the rows and columns in any given matrix. For example, if you try to see, this is here the screenshot of the same operation when you try to do it on the R console. So, let us try to do this operation on the R console and try to see that what do you get here. So, first we try to define here this matrix X. So, you can see here this is here like this, and now then I try to operate here the command row names on this matrix X. So, now if you try to see here this X, this will come out to be here like this, where the earlier names were like this 1, 2, 3, 4, but now the new names are here R1, R2, R3 and R4. And similarly, in case if you try to change the names of the column. So, let me try to give here some other name. Suppose if I give here the command here column names of this matrix X. Suppose if I try to give it here say apple, banana and say oranges. So, even you can do these things, you are simply giving the name. So, now if you try to see here, now the names are here apple, banana and oranges. So, this is how you can change the names of the rows and columns in any given matrix. So, now we come back to our slides and we try to learn some more operations. Now, suppose you need a matrix in which all the values should be the same. Well, these are the different type of operation which we need when we are trying to handle the real data set, and yeah, it is useful. So, my objective here is that I want to create here a matrix in which all the values are the same. So, suppose I try to create a matrix of order 4 by 2, that means there are 4 rows and 2 columns, and I want that in this matrix all the values should be 2. So, in order to do this thing, I simply write down here data is equal to 2, and if I use all these parameters in the matrix command, then and assign the value in a variable X, then X will come out to be like this. So, you can see here this is the first row, second row, third row, fourth row, first column, second column, and all the values are here only the 2. And similarly, if you want, you can choose any other value, and this is here the screenshot of the same operation when you try to do it in the R console. Now, similarly, when you are trying to do matrix operation, many times we need a diagonal matrix. The diagonal matrix is a matrix in which the off diagonal elements are 0 and there are only some non-zero values in the diagonal. You know that if you have a square matrix, suppose here, then all these values on this diagonals, they are called the diagonal element, and all these values on this so called triangles here and here, they are called as off diagonal elements. These are off diagonal, right. So, in case if you want to see here, then you have to simply use here the command diag, and you have to define here the values which you want to put on the diagonal. Suppose I want to create an identity matrix. Identity matrix is a matrix in which the diagonal elements are 1 and the off diagonal elements are 0. Suppose I want to create a 3 by 3 identity matrix, and in that case I will write down here n row equal to 3 and n col equal to 3, and then if I try to operate it, it will give me here this matrix in which you can see here the values of the diagonal element is only 1 and all other off diagonal elements, they are 0. Well, in case if you want, you can also do the same operation using the matrix command, but in that case you have to be very careful when you try to define the value of the data and the option by row. This data has to be assigned in such a way so that it is arranged in the way I want. So, in order to avoid those complications, this diag command directly gives us the diagonal matrix. And similarly, in case if you want to choose here some other value in the diagonal matrix, suppose I want to create a matrix in which there are 3 rows and 3 columns and all the values on the diagonal element, they are 5, and all the other values on the off diagonals, they are 0. So, in that case you have to simply use the same command here diag and then n row equal to 3 and col equal to 3, so that it generates a 3 by 3 matrix and the value on the diagonal elements is 5. So, if you try to see here, it will give you this type of operation. And Now you think that in case if I want to have a matrix in which the diagonal elements are like 1, 2, 3 and off diagonal elements are 0, how to do it? Think about it. But before that, let us try to first understand these operations on the R console. So if you try to see here, if you want to create such a matrix in which all the elements are going to be 2, then let me try to show you here. If you use the same command, it gives you here 2. And if you want to give here some other value, say 20, then if you try to see here, this will give you all the values in the 4 by 2 matrix as 20. And similarly, in case if you try to define here a diagonal matrix, say DIAG, then the data here is 1, and suppose I define here n row is equal to 4 and n col is equal to 4, then this will give me an identity matrix of order 4 like this. And if I try to change the value here on the diagonal, suppose I want to have 100. So now you can see here this matrix here is like this, where all the diagonal values are here 100. And as I ask you that if you want to suppose give here say values like here 4 values 1, 2, 3, 4 like this. So then how to give it? Means on the diagonal the values are 1, 2, 3, 4 and off diagonal elements are 0. So I can use here my logic and I can give here the data in the using the data vector command, and let us see what happens. You can see here now. So these 1, 2, 3 and here 4. So you see now you can think that how you can combine different types of operations which are possible in matrix theory, and then try to experiment with them, try to play with them and try to see what is really happening, right. So now after this I come to some more operations. I am sure that those who are familiar with the matrix theory, they must be knowing about the transpose of a matrix. Transpose of a matrix, that means the rows and columns are interchanged. For example, if I try to take here a very simple example like as here, if I take a matrix here 1, 2, 3 and here 4. So now in case if I try to find out the transpose of this matrix, then this rows and columns will be interchanged. So this first row, this will become here like first column 1, 2, and this second row will become here second column like this. So if you want to do such an operation in the R software, then how to get it done? So for that, suppose we define here a matrix of order 4 by 2 which has the data values 1, 2, 3, 4 up to 8 and by row is equal to true. And you know that instead of using true and false, we can also use here capital T and capital false respectively. So I try to use here T, and then gives me here this type of matrix in which the observations are row wise arranged. You can see 1, 2, 3, 4, 5, 6, 7, 8. Now I try to find out its transpose, because the command to find out the transpose of a matrix is simply T, and inside the parenthesis you have to write down the matrix. So if you see here, I try to write down here T and inside parenthesis this is X, and I try to give it a name, say here XT, and now you can see here this is change. So you can see here from the screenshot that this column which was 1, 3, 5, 7, now this becomes here a row. First column becomes first row, and this second column, this is 2, 4, 6, 8, this becomes here a second row. So this is the transpose operation, and you can very easily do it in the R software. Similarly, in case if you want to find out the sum of the values in the rows and columns, then how to get it done? So I will just take an example to explain you. So suppose I define here a matrix like this, which is a 4 by 2 matrix with the data 1 to 8, and yeah, it is here like this. So now in case if you want to find out the sum of the elements on the rows and columns, what does this mean? If I try to say here the sum of the values in the first row, this is here 1 plus 5, which is here 6. And similarly in the third row, it is 3 plus 7, which is equal to here 10. And similarly, in case if you want to find out the values in the first column and try to find out their sum, this will be 1 plus 2 plus 3 plus 4, which is equal to here 10. So in order to do such operations in the R software, which are required many times while doing calculations, we have a command here row sums and column sums. But if you try to see here how these commands have been spelled, for row sums it is ROW SUMS, where this S, which is the first S in the sum, this is capital, this is uppercase. And similarly, in the second command, COLSUMS, and in this case also this S is capital. So this will find the column sums. So in case if you simply try to give here the row sums or col sums, and inside the parenthesis you give the name of the matrix, it will find out all the sums. For example, you can see here, first you try to look here. You can see here row sums of x, it is 6, 8, 10, 12, and column sums of x is 10, 26 like this. So if you try to see what it is trying to do, it is trying to add here 1 plus 5, which is here like this, 2 plus 6 here 8, 3 plus 7 here, this is 10, and 4 plus 8, this is here 12. And similarly, if you try to find out the column sums here, 1 plus 2 plus 3 plus 4, this is here 10, and 5 plus 6 plus 7 plus 8, which is here 26, and these are the values 6, 8, 10, 12 which are given here, and these are the values 10 and 26 which are given here. So you can see here, right. So similarly, instead of finding out the sums, if you want to find out the arithmetic mean of the values in the rows and columns, then similarly those values can be found very easily. So suppose if I try to take here the same matrix here, which we have just considered for finding out the row sums and column sums. So we have this matrix here, and now we want to find out the arithmetic mean of the values in the rows and columns. For example, if you try to see here in the first row, I have the values here 1 plus 5. So the arithmetic mean will be here 1 plus 5 divided by 2, which is here 3, and similarly if you try to see the sum of the values in the first column, 1 plus 2 plus 3 plus 4 divided by 4, which will be equal to here 10 upon 4, equal to 2.5. Right. So in order to find out these means, we have the command here row means and col means, but you have to be very careful that here this M, this is in the uppercase alphabet, that is capital M. So the spelling here is ROW, capital M, EANS, out of which EANS is again in the lower case, and similarly in the column means COL in the lower case, col, then capital M, and then in the lower case alphabet EANS, and then inside the parenthesis you have to give the name of the matrix. So if you try to see, this is the very simple operation that if you try to look here, it will try to say here 1 plus 5, which is equal to here 1 plus 5 divided by 2, which is 3, then 2 plus 6, which is here 8 divided by 2, which is here 4, and then 3 plus 7, which is here 10, 10 divided by 2, which is here 5, 4 plus 8, which is here 12, 12 divided by 2, which is here 6. So this 3, 4, 5, 6, you can see here, this has been obtained here in the command row mean x, and the same output is obtained here 3, 4, 5, 6. Now in case if you want to find out the column means, you know that you have to find out the sum of the values in the first column, that is 1 plus 2 plus 3 plus 4, and then divided by 4, which will be here 2.5, and the means of the values in the second column, it is 5 plus 6 plus 7 plus 8 divided by 4, which is here 6.5, and you can see here these two values are appearing here in the outcome of the command col means, which are 2.5 and 6.5. So let us try to do these operations on the R console and then try to see how you can obtain them. So right, okay, so let us try to use our x, which we had defined earlier, but this is all 20. So if you try to see here the transpose of this matrix here x, you can see here all the values are the same because it is a constant matrix, and but the number of rows and number of columns are changed. Here there are 4 rows and 2 columns, but now here there are 2 rows and 4 columns. So why not to take the same example that we have considered here in our slides. So let us try to consider here the same matrix here. This is here like this. So this is the matrix here. So this matrix has 4 rows and 2 columns, okay, and the data is arranged like 1, 2, 3, 4, 5, 6, 7, 8, which are row wise. So now if you try to find out its transpose, then you can see here this is changed. The first row becomes here the first column, second row 3 and 4 becomes here the second column, and so on. So this is how the transpose operation is done. Now we try to find out the row sums, column sums, row means and column means. So let us try to use the same matrix. So if you try to see here, If I try to find out here row sums of here x, this will come out of here like this. 1 plus 2, this is 3, which is here like this. 3 plus 4 is this 7, which is here like this, and so on. And similarly, if you try to find out here column sums of this matrix here x, this is here like 16 and 20, right? This is 1 plus 3 plus 5 plus 7 is 16, and so is the sum of the 2 plus 4 plus 6 plus 8, which is here 20. Now, similarly, if you want to find out the row means here, you have to be very careful when you are trying to write down the spelling. So, the row means will become here like this. So, you can see here every row has got the 2 elements. So, if you simply try to divide 3, 7, 11, 15 by 2, you get here the row means here like this 1.5, 3.5, 5.5 and 7.5. And similarly, if you want to find out here the column means, so column means of x is obtained here like 4 and 5. So, there are 4 elements in the each of the column. So, if you try to divide the column sums by 4, you get the answer, which is here 16 divided by 4 is 4 and 20 divided by 4 is 5. So, now you can see here that these are very simple operations. These are very elementary operations also, but when you are trying to do the bigger programming, you write the big programs, then possibly these concepts are going to be used at many places, and that was my objective, that why I have chosen these operations. But now I have taken a very small number of operations so that you can settle these concepts inside your mind and you have time to practice it. So, you try to practice these commands, try to take some examples yourself and try to see that whatever calculations you are trying to do manually, is it matching with the outcome on the R software. So, you try to practice it, and I will see you in the next lecture. Till then, goodbye.